all over the world. I remain Sir Lumaj. Today we are going to be discussing the subject mathematics. Mathematics. The last lecture video was based on the introduction to the principle of mathematics. Today I'll be talking about the laws of indices as a topic. The laws of indices as a topic, because last week I was talking about signs, talking about alphabets, talking about integers. Today, this is another law that you are going to be using all through your life in mathematics, just like the way I explained in my last video. If you have not watched it, please go and do so that by the time I start mathematics proper, you won't get lost in the process. So we have 8 laws of indices. Number 1, I'll call it law 1. The rule says that what? Anything raised to power 0. And when you hear anything, I say anything raised to power 0 is equal to 1. Anything raised to power 0. Anything can be an integer, that is number, or it could be an alphabet. So for instance, if I say 4 raised to power 0, 4 is an integer, it's a number. 4 raised to power 0 is equal to what? 1. Even if I have 1 million, if I have 1 million raised to power 0, it's equal to what? 1. This is not for the mathematics class. I would have proved this to us with a differential calculus. So 4 raised to power 0 is equal to 1, because I say anything raised to power 0 is 1. So I proved it for a number. Then you can say a raised to power 0, alphabet now. A raised to power 0. A is also part of what? Anything. A raised to power 0 is equal to what? 1. Even if I have x, x raised to power 0 is equal to what? 1. If I have y, y raised to power 0 is equal to what? 1. That is what? Rule 1 in the laws of indices. In the second law, it's still saying anything with fraction 2. Anything with fraction of power. Let me just use alphabets now. Anything with fraction of power. If I have a raised to power m all over n, that how do I treat this? For me to solve this, the rule says that what? To solve this, and meanwhile, I forgot to tell you this. When you see a base as a number or alphabet carrying a power, that number that is, or alphabet that is carrying that power, is called a base. Under our laws of what? Indices. So if I have a raised to power n over n, the rule says that what? The answer to this is that the base, the nth root of this base raised to the power. So the denominator will be the root, while the numerator will be the power. I repeat, the denominator will be the root, while the numerator will be the power. For instance, in terms of number, let's say I have 5 raised to power 4 all over 3. For me to solve this, or let me use something that is more practical so that I can just, because this one will give me fractions. Let's say I have 8 raised to power 4 all over 3. The question is, how do I solve this? Or how do I simplify? That's the word we normally use in mathematics. Simplify 8 raised to power 4 all over 3. For how to simplify this, I said from the laws of indices that it will not be the third root of 8 raised to power 4. Third root of 8 raised to power 4. What's the meaning of this third root? It means that you should think of a number that can multiply itself 3 times to give you 8. Then raised to the power of 4. That's the meaning of third root of 8 raised to power 4. Think of a number that will multiply itself 3 times to give you 8. Then raise that number to the power of 4. Then you start from the first number, which is what? 1. If I say 1 times 1 times 1 is equal to what? 1. Go to the next integer, which is 2. 2 times 2 times 2 is equal to what? 8. So it means that 2 is the number that will multiply itself 3 times to give me 8. So the answer will now be what? 2 raised to power 4. It means that 2 should multiply itself in 4 places. So that you now have 2 times 2 times 2 times 2. And the answer will now be what? 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. It means that 8 raised to power 4 over 3, when you simplify it, the value will be what? 16. Very simple. Straightforward. Let's go to the next rule. Like I told us in other videos, if there is anything you are not getting as I'm explaining, you have to flip back. Watch the video again. By the time you watch it 3-4 times, you will understand it clearly. There is no magic. Mathematics is very simple. Everything is based on the principle. Once you understand the principle, you are good to go. Number 3, the third rule. The third rule says that if you have the product, or let me start with the product of a common base. Let's say I have a raised to power m, and they are having different powers, times a raised to power n. A raised to power m times a raised to power n. Don't forget, this is a base. This is your power. In my last video, if you don't want to call it power, you can call it superscript. So this is the power. This is your base. A raised to power m times a raised to power n. For us to solve this, the rule says that what? Take one of the bases. Take one of the bases, then add the powers. That is m plus n. When you have a condition like this that you want to solve, once they have similar bases, what you just do there is that pick one of it, then add the power if you are multiplying them. For instance, let's say I have 5 raised to power 3 times 5 raised to power 2. For you to solve this, you just simply say that 5 raised to power what? 3 plus 2. You have picked one of the bases, which is what? 5. Raised to power 3 plus 2. So it now become 5 raised to power 5. It means 5 should multiply itself in 5 places. We have 5 times 5 times 5 times 5 times 5. Then you multiply, then you get your answer. That is how to solve this. Another example, let's say I have 10 raised to power 4 times 10 raised to power 6. The rule says that what? They have similar base. So this is a base, this is another base. So we have similar bases. So what happens is that just pick one. When they are multiplying each other, they have similar base. This is 10, this is 10, they are similar. You pick one. So that is 10 raised to power of this. So you just change your times to plus. So it becomes plus 6. So this is 10 raised to power 10. You have solved it. That's what the rule is saying when you have multiplication of common bases. But when you have division of bases, when you have division of bases, let me just do this to save time. The same thing I will still be doing. Division of bases now. Division of bases. So when you have division of bases, maybe I have a raised to power m divided by a raised to power n. The rule says that what? Pick one of the bases. If I pick one of the bases, I will have a raised to power m minus n. M, remove the dots, it becomes what? Minus n. A raised to power m divided by a raised to power n. The rule says that what? Pick one of the bases because they are similar. This is it. Then take the power, subtract this from this. So it will now be m minus n. M, remove these dots so that you always remember. Just remove the dots, it turns to what? Minus. Subtractional sign. So we have a raised to power m minus n. This is the fourth rule. M minus n. So for us to solve this, let's say I have 5 raised to power 3 divided by 5 raised to power 2. The rule says that what? Pick one of these. Then we have 5. Then it will now be 3. Remove the dots. It becomes minus 2. So that is what? 5 raised to power 1. So simple. The next one, maybe I have 10 raised to power 6 divided by 10 raised to power 2. Same rule, they have common basis. So it will be 10 raised to power 6 minus 2. And that's what? 10 raised to power 4. As simple as ABC. The fifth rule, still following the same order. The fifth rule states that when you have different bases, maybe I have a raised to power m times b raised to power n. Look at it. Different bases, but similar powers. Different bases, similar powers. The rule says that what? Multiply the bases. That is a dot b. I've told you the meaning of dot. Dot means what? Multiply. A times b. We use dot a lot in further mathematics. They can use dot or they use asterisk sign. So when you see asterisk sign, when you see dot, it means product. And product means multiplication in mathematics. So we have these to be what? A, B raised to, just pick one of the powers, m. For instance, let's have 3 raised to power 2 times 2 raised to power 2. The rule says that what? Multiply 3 by 2. Then retain one of the powers. So it will be 3 times 2, 6. Then raised to power what? 2. So the answer is what? 36. Another example. Maybe I have 4 raised to power 3 times 2 raised to power 6. Sorry, 2 raised to power 3. They have similar powers, but different bases. The rule says that what? Multiply the bases, raised to one of the powers. So I have 6 raised to power 3. That is, we have 6 times 6 times 6. 6 times 6 times 6 times 6. That's the answer. It's as simple as A, B, C. The next rule, when you have anything, you can say I'm using the word anything. Anything could be integral, it could be alphabet. So that should be my 6th rule now. Rule number 6. When you have anything raised to power, then the whole is raised to another power. Let's say I have a raised to power m raised to power n. I have a raised to power m raised to power n. The rule says that what? Just take the power, the base, then multiply the power by the power. So you have a raised to power m times n. So this should now be what? A raised to power m n. Maybe I have, for instance, 5 raised to power 3 raised to power 2. For me to solve this will be what? 5 raised to power 3 times 2. And that's what? 5 raised to power 6. Is there any big deal? You have solved that. No big deal in this. Number 7 is still the same thing I'm doing. If you have a fraction, let's say I have a fraction, if I have a fraction multiplied by itself, let's say I have a raised to power, raised to power m all over a raised to power n. No, it's fractions. Before that one, I think I remember. Number 7, the inverse. Let's say I have a negative power. Let's say I have 4 raised to power minus 2. Or let me use alphabet, since I've been using alphabet. If I have a raised to power minus 2, a raised to power minus 2, the result is that what? The operation is that what? the result will now be an inverse of this. An inverse of this. If I say inverse, it means that it will be the inverse positive of this number. So we now have 1 all over a raised to power 2. Like I always tell people, I said this inverse, which is this negative sign, this negative sign will now be the one that will be standing. Then we now have power, positive power. Very simple. Inverse of this. For instance, if I say 5 raised to power minus 2. 5 raised to power minus 2. For you to solve this, it will now be what? 1 all over 5 squared. So it will now be what? 1 all over 25. Another example, I can say 3 raised to power minus 1. Now 3 raised to power minus 1. How do I solve this? Don't forget the rule. It will now be the what? The inverse positive of that number. So the inverse positive will now be what? 1 all over what? 3. No, this is 3 raised to power 1. Anything raised to power 1 is still that same number. So 3 raised to power minus 1 is equal to what? 1 all over 3. I can also have 3 raised to power, let's say minus 4. It means that I'm going to have 1 all over 3 raised to power 4. Then you can solve, you can simplify further. So that would now be 1 all over 3 times 3 times 3 times 3. 3 times 3, 9. 9 times 3, 36. 36 times 3, that is 108. So you can now say that the result is 1 all over 108. So the last rule, which is the 8th rule, it says that when you have fraction of a power n, a over b raised to power n. I remember the last rule. Yeah. Say a over b raised to power n. For you to solve this problem, each of the the fraction will now carry its power. How do I mean? It means that for me to solve this one will now be a raised to power n all over b raised to power n. For instance, let's say I have 5 over 4 raised to power 2. For me to solve this will be what? 5 raised to power 2 all over what? 4 raised to power 2. And this one will give us 25 all over what? 16. 25 all over 16. So those are the 8 rules in indices. Let me just give us one question that will combine the rules. I can just say simplify 10 times 10 raised to power 7 times 10 raised to power 8 divided by 10 raised to power minus 17. Very simple. The first thing we have to look at, do they have common base? Yes, they have common base. So I can carry out the operation. If they have common base, if you want to leave this and solve this, you can go ahead. If I go step by step now, that is even better. 10 raised to power 7 times 10 raised to power 8. That is 10 raised to power 7 plus 8. Applying the law of indices. Divided by 10 raised to power minus 17. So you're going to have 10 raised to power 15 divided by 10 raised to power minus 17. And when you add division of common bases in the law of indices, you have to pick one. This one would now be 10 raised to power 15. Remove the dots, it becomes minus, can you see? What's there? Minus 17. So this one will now be what? Can you now see that we are, okay, no, we see what I want to do now. So you're going to have 10 raised to power 15. Now look at it. This is minus bracket minus 17. From the first video, I taught us product of signs. This is minus times minus. Minus times minus is what? Plus. 17. So that will now be what? 10 raised to power what? 15 plus 17. That is what? 32. In the first video, I told us that we are going to be applying signs. Can you see where we are applying it here? The same way, in our future calculations, we are going to encounter calculations that will involve the use of the law of indices. I want to believe this short video has made a whole lot of exposition to us. Please try and subscribe. I want to appreciate each and every one of us that are really encouraging me in doing more of this video. Please subscribe. God bless you. Stay blessed.